This week we'll be working on composite functions. So composite functions, we just do one or more operations to two different functions. So we could have f of x and g of x, whatever they might stand for. And then the notation would be f of x plus g of x. If we're adding those functions together, it'd be f of x times, or let's just do minus g of x, and you do that in the other order too. F of x times g of x, and then f of x over g of x. But for that last one, you have to also state where g of x does not equal 0, because if it equals 0, you can't have that function. So the sum of two functions, so we're going to take f of x plus g of x, which would be 2x plus 3 plus x squared. Now, there's nothing here that will combine together, so our final answer will be x squared plus 2x plus 3. Difference, so f of x minus g of x, and then we can also do g of x minus f of x since order matters here, so I'm show the two different ways. Here we'll have 2x plus 3 minus x squared. Notice how I use parentheses just to make sure we keep track of all of our signs. So this would be negative x squared plus 2x plus 3. Over here, we have x squared minus 2x plus 3, which is x squared minus 2x minus 3. Multiplying, order doesn't matter, so f of x times g of x is equal to g of x times f of x. It's the same thing either way. So we'll have x squared, 2x plus 3 would be 2x cubed plus 3x squared. Dividing, so only thing you gotta be careful of here is that the denominator cannot equal 0. Order matters, so we can write two different ways. First one would be 2x plus 3 over x squared, where x does not equal 0, because then that's the only place where x squared equals 0. For the other one, we'd have x squared over 2x plus 3. To figure this one out, it's a little bit of basic math, but you can also just set 2x plus 3 equals 0 and solve. So you get 2x equals negative 3, x equals negative 3 over 2. So this is where x does not equal negative 3 halves. So then for composition, this is something new. This is where we're going to take g of x and plug it in for f of x. There's two ways you'll see this talked about. There's f of g of x, or you'll see it as f of this open circle, almost looks like it says fog of x. Either way, what that means is you take what g of x equals and you plug it in wherever you see an x, an f of x. So we would have 2, and then we're plugging x squared in for x plus 3. So that would be 2x squared plus 3. If we did it the other way, so if we did g of f of x, also g of f of x, either way, that would be 2x plus 3 squared, which would then give us 4x squared plus 12x plus 9. For the last example here, so f of g of x, that means we're taking g of x and we're plugging it in wherever we see an x. So this notation here, you basically start on the furthest inside and then work your way out. So we have 2x minus 4 squared plus 4x minus 4 plus 3. That'll be 2x squared minus 8x plus 16 plus 4x minus 16 plus 3. 2x squared minus 16x plus 32 plus 4x minus 16 plus 3. Simplify, we have 2x squared, we got 4x and a minus 16x, which is minus 12x, and then 32 minus 6 plus 3, 35 minus 16 is 19, so plus 19. We do it the other way, we'll have 2x squared plus 4x plus 3 minus 4 should be 2x squared plus 4x minus 1.